Hello, my name is Charlie Norris, the Automation Product Manager here at WAGO, and with me is Mark D. Kramer, our Product Support Manager. This short video is an introduction to the TouchPanel 600 control panel. We will cover features of the control panel, discuss possible architectures, and show you how to set up communications using eCockpit. The TouchPanel 600 control panel is an integrated PLC and HMI. It is an all-in-one solution for your automation applications. In a control panel, all of the PLC logic and graphic visualizations are stored and run from this device. WAGO's eCockpit engineering software tool is used to develop both the PLC code and the visualizations. And I would point out that the controller has a 4-core processor, each of which is running at 1 GHz, providing the user with high performance. And I note that the control panel does not have a local I/O bus. So for distributed I/O, the controller can be paired with a WAGO coupler with an Ethernet-based protocol or perhaps a CAN open-based protocol. An advantage of the WAGO Cloud Panel is that it is IoT ready. Much like WAGO's PFC 200 platform, this device supports protocols that are utilized by most cloud services such as MQTT. Many cloud applications leverage the advantages of the lightweight MQTT protocol, so it is very easy to exchange data directly from the control panel to your favorite cloud. We also support the MQTT-based Sparkplug protocol for exchanging data with on-premise and cloud-based SCADA systems like Ignition. And the device also supports OPC UA, that is a universal for the exchange of data with many enterprise-wide systems. In addition, the control panel's operating system is real-time Linux that can run Docker containers. So if you have an application that operates in a Docker container, you can run it in parallel with an eCockpit application. So the control panel is a great choice for your IIoT applications. The control panel can also be transformed into an EtherCAT master via a license. The control panel has 2 Ethernet ports on it, so when you use it as an EtherCAT master, one port is used for the EtherCAT network, and the other port can be used to connect with other systems via an Ethernet field bus or an IIoT protocol that I just mentioned. The EtherCAT port can be used to connect with WAGO's or other manufacturers' EtherCAT-based distributed I/O, or perhaps a variable speed drive or a sensor. You may ask yourself, when would I use a control panel? I think it's a fantastic choice for OEMs that want an HMI and a PLC on their equipment. They can save panel space as the unit is a combination of the PLC and HMI, and then use distributed couplers for the I/O. So the advantage of the control panel is that it is a single device that combines a PLC with an HMI. It supports most of the popular field buses, so it can be used as a gateway to many different types of devices. It supports Modbus TCP, CAN Open, EtherCAT, Ethernet IP, and serial interfaces like RS-232 and 485. It is an IIoT enabled for direct connection to a cloud or enterprise-wide SCADA system. It can also run Docker containers in parallel with your eCockpit applications, and all the tags for your PLC and HMI are in one unit. So when using a control panel, you need to consider that there is no local bus, so you can use one of the supported field bus to connect to distributed I/O. And I would also note that via field bus you can exchange data with WAGO and third-party PLCs. This is the view of the control panel's interface ports. It is what we call the PIO3 configuration. There is a 24-volt DC removable connector to power the device. It does have on board 4 configurable digital I/O points. That is, you can configure each point to be either a digital input or a digital output. This is very convenient if you have some push buttons on your control panel, such as a start-stop button for your equipment or if you want a push button to set the display to a home page. There is a configurable serial port for RS-232 or 485 communications. It also has a CAN open port that supports J1939. So this is a great way to communicate with large diesel engines in an engine monitoring application. It has two configurable Ethernet ports. That is, you can configure the ports to act like a switch, or you can set them up as independent ports with separate IP addresses. The control panel also comes with an onboard firewall and VPN. So if you're concerned with network security for your application, you can enable the firewall and or the VPN for enhanced cybersecurity. The device has two USB ports that can be used with an external keyboard and mouse, and it also has an audio port if you want to provide operators with an acoustic feedback. On the side of the control panel, there is a run-stop switch. There is also a micro SD card slot that can be used for additional data storage or for backing up the application, or it could be useful for updating the firmware. There are several status LEDs to provide a quick view of the controller's status. Next, Mark is going to show you a demo of the control panel. This is the diagram of the architecture of the demo. Mark will use the eCockpit software to set up the EtherCAT communications with the distributed I/O and develop the PLC program. Then, in runtime, the control panel will manage the outputs on the EtherCAT coupler. So I think Mark is ready to show us how it's done.
This is the 10.1-inch advanced line control panel, which has the capacitive touch glass surface. In this demo, I am showing the EtherCAT master functionality of the panel. I have a WAGO node of EtherCAT I/O that uses the 750-354 bus coupler. This node has a couple of 16-point digital output modules, and these outputs are being controlled by an eCockpit project running on the control panel. Here is the eCockpit project containing the visualization and logic that controls the outputs on the remote EtherCAT node. Similar to what you saw earlier, there is a nice configurator in eCockpit that allows you to build your network of EtherCAT devices and map the data as you like. I have two buttons on the visualization that cause the outputs to rotate in either a counterclockwise or a clockwise direction. I also have a speed control, which as you can see controls the rotation speed of the outputs. There are also indicators that show the active output states. Hopefully you can see that the update time of the control panel is very impressive, as the indicators follow the actual outputs very closely. And that is my TP600 control panel demo.
We hope you found this information helpful. If you have any questions on the TouchPanel 600 control panel, please contact your local WAGO representative or give us a call. Additional information such as product data sheets and manuals can be found on our website at wago.us. Thank you for watching.